So I have the great pleasure of being joined today by two very, very interesting individuals who have been working a lot on the future of modern defense technology. I think to kick this off, we don't usually do big intros. We just put your name up there and get straight to it. So I think to kick this off, for the fun of it, I'd like to talk a little bit about, for those of you maybe got a show of hands, has anyone been tracking the spiderweb attack in Ukraine? Okay. For those who don't know, the Ukrainians managed to get a bunch of drones on the top of trucks, launched them remotely, and took out like 40-odd strategic bombers. So I think that kind of is a good entry to what's going on in defense and what the possibilities are. When I saw that, my thought was, boy, I hope someone doesn't do that to us, right? And so I think, Ed, maybe you can talk a little bit about what you guys have been working on that helps deal with these kinds of issues and kind of brings us into the modern era in terms of not being quite so vulnerable.
Yeah, so I think, traditionally, like, there's this famous saying around the actual war happens in the factories. I think that's very true. I mean, we can kind of see it now. We had kind of a period of where we focused a lot on bespoke weapons. These are weapons that took a lot of money, required a lot of advanced technologies, took a long time before we can manufacture them. And then we realized that you can have a $100 million fighter jet, and if it's a single, few $100 drone can destroy it, then you're in deep trouble, right? So it seems like there has been a shift, right, in that type of warfare, and I'm sure Travis will talk more about it. And the recent attacks by Ukraine is representative of that. Well, what does that mean? That means that we need to get cheaper manufacturing, right? A lot of our manufacturing recently had been offshored to Southeast Asia in the past few decades. We need cheaper manufacturing here in the United States because now it's becoming a national security challenge. But it needs to be also more flexible. We need to be able to more easily adapt to changes, manufacture different types of products, different types of material. And that's the challenge we're kind of trying to address at Machina Labs. We're developing new manufacturing technologies that uses robotics and artificial intelligence to actually have a system that can easily change a design, easily can change a material, as opposed to traditional factories where the factory is pretty much built for the product, right? The moment you want to change the material, you have to change the factory. So we're trying to create these agile technologies using latest robotic and artificial intelligence methods that can easily change a process, go from one material to another, from one product to another in a matter of hours as opposed to years that it is today.
And Travis, you deal with a lot of different technologies. So for anyone who doesn't know, DIU is now has $1 billion in funding per year, I think, and you can talk more about where that's headed. And that I think is a very good thing. And they're therefore expanding and looking for all sorts of technologies. Maybe you can talk a little bit about some of the programs that you guys are running now and what you're expanding into.
Yeah, certainly. Thanks. So my name is Travis DeMeester. I lead the Defense Innovation Unit's efforts in advanced manufacturing, and very much with the mindset of what Ed said is the wars are won and lost with logistics and manufacturing, and those aren't the things that you necessarily see on the front end, but those are the things that we track closely. So Defense Innovation Unit was founded in 2015 by the late Ash Carter. Our headquarters is in Mountain View, California, right in Silicon Valley, and it was really meant to build a bridge that had frayed between technology developers in the commercial sector and what was happening in the Department of Defense. We spent a lot of years just trying to find our way on how to best innovate, how to work with commercial technology companies. And now that we're really finding our way, almost true to how a startup would work, now we're scaling those efforts, and I think some of the recent budget actions reflect that. So we have several technology portfolios where we focus on defense-relevant technologies, but our job and our purpose is really to understand what's happening in the commercial sector, work with companies that might not necessarily be working directly with the department to help leverage the best of the technology that they're developing there. So we've got a host of programs that scale from across different technology types, early TRL to late TRL, and now we're starting to focus a lot more on manufacturing in particular.
And both of you kind of work a lot on manufacturing and industrialization, like Industry 4.0 stuff, and in some very interesting ways, I would say. So maybe this is a two-part question. It's one part from each of you, but we like to look out like 3 to 5 years into the future. What are you picturing, in the factory that you see in the future that's making these things? What does it even look like?
So I think big component is what we talked about, right? It needs to be easily changeable, right? You know, I spent kind of my early years in manufacturing was spent at SpaceX. You know, you think of company like SpaceX at the forefront of manufacturing to some extent, right? Was founded in 2001. It's now 2025. They have made 2 propulsion platforms, right? In the span of 25 years, we have Falcon family and we have a Starship family. And Starship is not yet productionized. They're still testing it. Why? Because once we decided on diameter of the Falcon 9, once we decided on the material that goes into Falcon, that whole shop floor was tooled for that specific vehicle, right? The moment we wanted to decide to change its diameter, that means hundreds of $millions in investment in tooling and equipment, right? So you cannot easily change it. Actually, there's like a funny story is that Falcon 9, if you look at it has 3 versions, or Falcon in general, went from Falcon to Falcon 9, and then the next version. They kept getting taller, but could never get larger in diameter because the tooling for the diameter could not change, right? And then as a matter of fact, when they started the next vehicle, Starship, they had to completely start from scratch in Texas in another facility, a whole set of new tooling. So I think the core of what we're going to see in the future is that factories are going to become what we call more software-defined. Instead of defining them with the hardware tooling, define them with just a program, right, that can easily change. So what does that mean? That means that we're going to have these units of manufacturing that can do different types of operations on different types of material. Almost it starts to look more like a data center, right? You're going to have a facility that's going to have these flexible manufacturing units. At Machina, we call them robo-craftsmen. But then you have a facility, you're going to have 200, 300 of these, and you can program each of them to do different operations. Few of them will do forming, few of them will do welding, few of them will do assembly. And then in the morning, you can do missile parts. In the afternoon, you can reprogram it to do automotive parts, right? So that's, I think, what it's going to start to look like. What does that mean also is that the manufacturing is going to start looking distributed, right? If you have this unit of manufacturing that is standalone and it can be programmed to do different things, you can easily deploy it to any area, right? So yeah, distributed and flexibility, I think, is just going to be key characteristics of what I see in the next 10 years.
Very similar, and I think modularity of production is going to be king. And I'll take a step back and kind of circle back around to that. So you mentioned Industry 4.0. It's a really interesting idea that I think a lot of people hear that and they think it's a handful of technologies that are going to be integrated in manufacturing. But the genesis of the term it's the 4th Industrial Revolution. And I don't think people take the term industrial revolution seriously enough. And as you have these converging technologies, you've got cloud, and you've got IoT, and you've got distributed sensing, and you've got, of course, AI and data analytics and machine vision. You've got new manufacturing processes that are coming online. You've got new materials that we hadn't even thought of years ago. You've got modeling and simulation. So in the digital world, you can do these advanced production methods virtually first to test them and try them and refine them, right? So you have all of these technologies converging, and we're gonna pretend like we know what manufacturing is gonna look like in 10 years. I think timing wise, not really sure, but where this converges is that manufacturing as it looks now is going to be much different going forward. The supply chains are going to be different. The type of people we hire are going to be different. Are going to be different. The cultures of these organizations, how they align with each other, and I think most importantly, how information is exchanged between different businesses in the value chain. And so 3 to 5 years, I see it looking a lot like a data center SaaS type model that we saw being developed in the early, in the 1990s into the early 2000s, where it doesn't matter as much on what a particular tooling that place has and what material they can work with. Like, we need a modularity to the system so that interchangeability is alive and well. That gives us agility in the supply chain, et cetera, et cetera.
Yeah, and I think modularity, we're seeing it now, right? So I would guess that you're looking around the world right now and thinking, okay, well, we got to get a lot better at, making this and making it in a way where it can't be just destroyed or disrupted in a single location. Ed, I know you did a LinkedIn post right before we came on here, and you're kind of going through Sun Tzu's Art of War and thinking about the different things. Speaking of, complete revolution. You were just comparing. It's like that concept still applies, but here's the way. Do you want to talk a little bit about some of the things you were getting at there? I know you were getting into some pretty interesting stuff there, and people should read that post, by the way. It was fun.
No, absolutely. I mean, as I was coming here, I was thinking about, okay, how does manufacturing going to change kind of defense landscape, right? We really talked a lot about distributedness, but think about the implications of that, right? A lot of our defense products, I'm not going to name them because I don't know if I can, but they rely on single source, right? There's one place out somewhere in our country that's manufacturing that component, right? So that's a huge kind of failure point, right? So being able to more easily distribute manufacturing in multiple locations, not only within United States soil, but with allied countries, right? Completely changes the landscape, the strategic landscape. We're looking at more asymmetric warfare, right? So that means that we might go into a region and we need to some extent be self-sufficient and not necessarily rely on kind of the supply chain that we have back home, right? How easily can we kind of bring up a new supply chain? Let's say we go into Pacific in friendly countries, in Thailand and some of the other countries that are friendly to United States, and be able to more rapidly, not in a matter of 2 years, 3 years, bring up a manufacturing facility. In a matter of a month or two, bring up a manufacturing capability that can repair our weapon system, that can deploy new weapon system, that can give us flexibility to do different types of the same weapon system, right? So think about, you have a drone and you want to start thinking about, okay, for this mission, I want long range, right? So I need maybe bigger fuel tank. But for this other mission, I need to carry a higher payload and I need larger wings, right? How easily can we kind of adapt and change the designs? These are all comes down to, having that distributed manufacturing, flexible distributed manufacturing that Travis was talking about.
And Travis, I think one common thing that I see in the startup community is that folks don't really know how to interface with the government. And I think that's kind of, in one way, probably one of the biggest roles you play is like, hi, here I am. Can you maybe do like a brief rundown on what it's like to interface with DIU and what you're looking for? And, in a community like this and tech in general, what are you out hunting for? And how does it work?
Yep, sure thing. So DIU is best thought of as a platform. One side of our platform entirely faces the commercial technology ecosystem. So we want to know where you are and what you're building and how that makes a difference and understand it well enough to understand if it could be repurposed and used in defense cases, et cetera, et cetera. And the other side of DIU faces internally into the Department of Defense. Contrary to popular belief, there's no single memo that comes out that says all the different things that the DoD is working on. We actually have to knock on doors and call people, and do you know this guy who knows this guy? And then suddenly you find your way to a program that makes sense. But the goal there is within the DoD to find strategic level problems, big thorny problems that could be solved using commercial technology. And so we've gotten very good at that. We align ourselves, again, with different portfolios to get to that, and we work across all of the services within the DoD. And so the question is, where does that become relevant for you, the technology developer? So you might laugh at me if you've ever worked with any government organization, but we actually have an email address, info@diu.mil, that does actually get serviced, and we care a lot about that because
Will you personally promise that the email gets answered?
I will. I promise. It is not a black box. We consider that our greatest asset. More than any other organization in the department, we need to know what is going on in the commercial sector. So we value those relationships. We value that communication. That's the easiest path and the most effective path, quite frankly. So when we find that compelling problem worth solving, we publish basically a solicitation. It's like an RFP, but the bar is really low. We don't expect that you've worked with the Department of Defense before. Work with a lot of companies that don't have the basics, like they're registered on sam.gov, or they've got a cage code, or any of these common things. Not worried about initially. We can work with you to get there. We publish these solicitations. We do a competitive down select. It moves quickly. Our baseline is 90 days from when we first publish the solicitation to when companies are on contract. After they're on contract, we do a 1 to 2 year prototyping period. The entire purpose of that is to make sure the technology works within the Department of Defense context, and we can do development alongside of that to enhance or upgrade any of the parts that are needed. The magic here is that once a company successfully completes that prototyping effort, we give them a success memo, and with that success memo, they can be sole sourced into production anywhere within the Department of Defense. And so our way of crossing the valley of death is that when you see a solicitation from DIU published, we've already done the work to find where that's going to land in production so that it's not just an open-ended R&D project. That's point one. A large part of the organization is devoted to that. Another part of our organization used to be called the National Security Innovation Network, ENSIN, and all of their programming has rolled up into DIU now. And so there's several programs for earlier stage TRL, for developing new people. So if you've ever heard of the program Hacking for Defense, 10 years ago, myself and a colleague did the first Hacking for Defense expansion class right here at UC San Diego. That's now a DIU program. So there's talent and there's venture and there's programs where we help pull IP out of universities or federal labs and coach teams on developing that IP for defense purposes, et cetera. So a whole host of programs, and all of those in general are available on our website with solicitations. We do prize challenges, hackathons. All of these are orchestrated and come together for a bigger strategic purpose.
All right, now I have a kind of a fun one for both of you. I don't want to make you pick too few, but probably we don't have time for too many. So if you had technologies that you kind of think are your favorites that have the biggest promise, which couple would you pick?
Roboforming. Well, there's some truth to that, right? Like I'm sitting here preaching modularity in manufacturing. Ed and his company have developed a very modular production technology, so I love that. I'm going to say AI because we have to. The promise is big. Ed and I were actually on a panel, AI for manufacturing, just a couple months ago. And I think that's a space where a lot of the hype that you see about AI is in use cases for enterprise SaaS or for personal chatbots or whatever it may be. But if you dissected a manufacturing company into all the things that it does, there are a lot of places where AI can and will make a big difference there. So I'll start with those two. Ed, do you want to pile in with a couple?
Obviously AI is a winner here. I think, the way I think about it is, we had this massive explosion of generation using AI in the virtual world, right? We can create videos now. Obviously, text was the first one that came. Well, now there's videos, there's images. But it's all in virtual world, right? We're not really affecting a physical world yet. So, it's kind of odd that, we became this, service-based economy, and then we're kind of made our own job a little bit obsolete. A lot of virtual services are getting kind of covered by AI. Obviously, it takes some time to fully cover it, but there's a missing gap from the virtual world to the physical world. How can we translate that, kind of exponential explosion of creativity into the physical world? We still drive, the same car. All of us, we almost drive the same cars, right? It's just very hard to make rapid innovation in the physical world. Peter Thiel has this famous saying that we were promised back in the 50s, 60s, we were promised flying cars, and then we got 144 characters, right? So that link still is missing, right? We cannot really iterate in the physical world. I think AI with some of these agile technologies like 3D printing, like roboforming, I think is going to be the key to translate that virtual idea generation into a physical world. Go from build me a panel for a fighter jet that does certain things and then make it a reality. Because right now that link is completely missing. So I'm really excited about kind of convergence of AI into the physical world. Obviously, there's a lot of development needs to be done on the energy side, which I'm really excited about to enable these. Right? We need a whole lot more in energy production to be able to both enable manufacturing side and also the AI side. So I follow most of those companies who are kind of operating in that space, especially in the nuclear space.
Yeah, I've got one more too that just came to mind. I think all of us now are sleeping a bit on quantum, right? It's coming along, but the hype cycle has since passed, and now you hear some news here and there, but is it really a thing? And I think a lot of us are just thinking about that in terms of either breakthrough drugs or password cracking or a handful of use cases. But when I think about the physical space, which for manufacturing or for defense is a big part of it, the materials drive a lot of that, right? And especially now with technologies like 3D printing, the supply chain is changing a bit in terms of I just need a powder of something or a wire of something for the most part, and it can have drastic effects on the performance capability and how easy it is to build, et cetera. So materials suppliers are gonna have real power in this space. And we think about materials development, getting your head around how big of a problem that is, I think is important. You can take a fairly, not the heaviest of molecules, but a fairly heavy molecule, and in every different way that you arrange that molecule, you get something with different properties, right? And with a fairly heavy molecule, if you were to test every possible combination of arrangement of how that molecule was built, it would fill up 1.5 universes, like all of the space everywhere, just with that one molecule trying all the different combinations. And so how do you even think about exploring the possibilities of what those materials could do? And I think AI is laying the groundwork for that. But once we're able to use quantum computing with that, I think suddenly getting to really, really effective materials that have properties that we're only dreaming of today, I think is going to be a really big deal.
I think maybe we can end on a fun one here. We were talking a lot about risk. This kind of, I think, just generally rising risk. And I was talking about on a panel yesterday, I believe, the compounding risks that seem to be happening. And I think people that work in defense always have the most interesting creative thoughts and things that keep them up at night. So I know it's a bit, passe, but maybe like a risk that you worry about that you think people don't see or don't understand well enough, and then an opportunity. So we end on a high note of what can be done, or businesses that could be successful.
I'll start with a couple ideas that lead to that. Buy you a little time to think of a good one. Come back. Yeah. I think risk is a really important concept here, and oftentimes in technology development, it's not about the efficacy of the technology itself. It's about how we commercialize that and accept it into society and change businesses to incorporate it. And there's so much needs to happen from when you get a great technology to when it actually does something, right? There's a lot of human inertia that needs to be overcome there. The Ukraine example is a great one in that I have seen briefs forecasting that now for at least 5 years. I think some of them go back a decade, right? People pounding on desks in the Pentagon saying, this is your future, and then like, well, that's not an F-35. That's just a little FPV drone, like not a big deal. So I think the question that I think is really important that ties together all of this is how we as a society decide to manage these risks. And on one hand, you have you can 3D print a firearm now. That is not a big lift these days. Well, how do we manage that? Do we make the IP behind that illegal to own, or like just thinking about how these things get managed and governed in a society where individuals are being armed with more and more powerful technologies? How do we think about not restricting the development so we can get the good out of it, but at the same time keeping our societies safe and manageable? So I'll start there, and I'm going to think of a good specific.
I think one major, I think a lot of people in the defense community know this, but I think a lot of people maybe like in the civilian world and in the commercial world don't fully realize this, is that we do not have a solid industrial base. We don't even have a close to really reasonable industrial base. We talk about interdependent world, and I think for the past few decades, we kind of like outsourced a lot of our industrial base to Southeast Asia. Most of our jobs turned into like service information-based jobs on top. But we forgot that there's this rug that we're standing on, and it can be pulled from underneath us. When I'll give you an example. When we were at SpaceX, the goal was not really to be a full stack vertically integrated company, right? We slowly became a vertically integrated company because there was no vendors, right? We're like, oh, we want this thing. Oh, that costs $2 million. I was like, why does it cost $2 million? There's only one guy doing it in this city, and then, and then that's how much he charges. And we're like, well, how come nobody else does this? This sounds like a trivial thing, right? We start bringing them in-house. To the point, at some point, I even thought about like bringing bolt making in-house, which was too far. But but you kept having to. The reason it became vertically integrated was really about the fact that the industrial base does not exist. So we and a lot of other companies, we're developing new manufacturing technologies, but who are we going to sell it to, right? If nobody exists, and even the ones that are existent, like over the past few decades, the primes sitting on the top of the kind of the chain have been optimizing this complicated supply chain that does exist to be having a very small, slim margin. So they don't have any strategic capital to deploy. They cannot invest in new technologies, right? So by default, by optimizing, we kind of disabled ourselves a little bit. So I think our job is pretty tough, right? We will see a lot of companies in this space having to go very vertical and do a lot of things, not just having a new technology that can form sheet metal, can 3D print, but actually go further down the stack and deliver something that can be used by the final customer, be it government or primes. And it's going to be a tough road ahead. And we also need a massive culture change because we also devalued these type of jobs, right? We were go become a keyboard person. Don't go in the shop floor. Don't work. That's not a good job, right? So we also need to now overcome this cultural challenge of also kind of making these jobs attractive again. So yeah, that's, I think to me is the biggest risk, right? It requires a lot of gusto, and potentially even massive cultural change and cultural shifts before we can kind of, turn it around.
I think if you look at what China has done to outcompete us in several industries, it's both frightening, but I think there's room for some optimism. So solar, right? Good luck starting a solar manufacturing company in the U.S. EVs, right? That story is starting to shift that way. Small UAS, DJI makes 70% of every single drone in the world, right? They've got a great ecosystem. You can't compete with them. They're too cheap, too fast, too well integrated. 3D printing added to the list of technologies invented here or in Europe that are not owned by either anymore. 3D printing is starting to go that way. And we're not talking about copycat technologies. We're talking about better IP that has higher quality and higher throughput and much higher volumes. So think now print farms being deployed with hundreds of printers per facility that drastically eclipse any quality or throughput capability of what we have in the U.S. And so I think the door is still open there, particularly as that tech evolves. But I would look to batteries. I think batteries are really, really important. They rely on a lot of materials that we don't necessarily have supply chains for in the U.S., but we still have time, and that demand is not going away. Like batteries, as long as I'm going to be alive, are going to be important, right? And anything related to batteries and power generation, I think that's the next game. And if we're not competing now, then we're already losing ground because China is.
One positive thing I'm going to add to that is that, we talked about the challenges and the risk, but I think as a country, we're a fourth quarter kind of country, right? We get excited in the last minute and kind of catch up. So I still believe in us. I think we can kind of catch up. I think once we feel the threat, we really kind of put an effort behind it. So still not late, but I think, we're getting close to fourth quarter.
I like that. I think that's a great note to end on. So thank you, everyone, and we'll see you soon.
Wonderful. Thanks a lot.